All right, the second question was more U sub, but it's a definite integral, so it's evaluating your ability to do U sub with a definite integral and the communication that requires. And I also asked you to leave your answer in exact form, which I guess was another skill as well. So let's chat about this question. So first and foremost, we need to figure out what it is we're doing with this problem in terms of a substitution. It's not one that makes us feel really confident that it's going to work for U sub because we have a bunch of other techniques like the trig sub we learned last class that could work here when we see that square root going on there. In fact, a lot of times you can do trig sub and it's just sort of like complete overkill. But first things first, we should always check, does our Calc 1 technique of U sub work? And so if we're going to do U sub here, the thing that makes sense to consider as our U is that inside function, the function that is inside of our square root, right? The whole point of U sub is we're undoing the chain rule. We are dealing with a composition of functions, and here's where we see our composition. I saw a number of students set their U equal to 2x minus 3, but that doesn't show the understanding of U substitution as how we deal with a composition of functions. So we have our composition, U is equal to x squared minus 3x plus 1. And we get immediate confirmation that we're on the right step or right path because when we take the derivative of this, we end up with 2x minus 3, which is exactly what we see in our numerator. So there we go. Pat on the back. We're doing the right thing. Now, as it is, we can go ahead. I almost made this too easy. We don't have to adjust our U or our du at all. We can go ahead and replace all that stuff I circled in red with du. We can replace the radicand in that denominator there with a u, and then we can put everything else back, except for we're gonna end up in some trouble, but that's beside the point. We'll get there in a second. Now, if you put everything back, like I just said to do, and you put a 5 and a 3 here, I circled that, and you scored at most a 3 out of 4, even if you did get to the right answer, because your communication for this moment in time is incorrect. If I were to type this into a calculator or into any sort of system I could solve this, it's going to give me the wrong answer, right? So these are not values of u. They should not be on this definite integral. So I like to use what I call method 1 for dealing with these. I don't really call it method 1, but one of the methods, which is to just make sure we're always writing equivalent statements. So if this is my original definite integral, I still want to write a definite integral here. I just want it to be a true definite integral. And so if I need this to be a true definite integral, I have to go figure out what those new bounds are in terms of my u. And here's the nice thing. I have a rule for what u is. So I just need to plug in those x's that were my original upper and lower bound, my limits of integration, into that formula, so then we'll be good. So u is, for my upper value here, I'll call it b, is going to be, I'm going to plug in 5 squared minus 3 times 5 plus 1. So 25 minus 15 plus 1, that's 11. So I can go ahead, erase that 5, put in my 11. And I can do the same work with the 3, my lower limit of integration here. 3 squared minus 3 times 3. Ooh, those cancel. Plus 1. Cute. Now, again, we might have to do a little bit of work if we didn't see it immediately. We're going to have to rewrite this as u to the negative 1/2. But we're writing down statements that if I typed each and every one of these into a calculator, it would give me out the exact same value, 4.68 or whatever it was. So go, okay, I can take the antiderivative now. We're back down to a power rule. This is going to be u to the 1/2 divided by 1/2, which is times 2. And we're going to evaluate that 11 and 1. So fundamental theorem calculus time, we have 2 times 11 to the 1/2 minus 2 times 1 to the 1/2. Some of you left this like that. That's fine. A cuter version is to go ahead and give me this with that square root symbol, because that's how my original problem started. So we like to give things back the way they were originally presented to us. And then the square root of 1 is just 1. So here's our perfect exact answer. If you went further than this, you told me 4.6, whatever the heck it was. Again, you kind of got maxed out here. I actually gave you half a point. So I was a 3.5 out of 4. Okay, so What is the other way if you don't like doing all of this? I love this because the communication is clear, easy. Every time I'm writing an equal sign, I am truly giving you something equal. The other method is if you don't want to deal with the bounds and you're really confident in your indefinite integrals, you take a moment and you just solve out this problem or deal with the indefinite integral instead. You go, okay, cool. That's going to be the indefinite integral of u to the negative 1/2 du from all the same work we did above. I'm not going to redo it, which is equal to 2u to the 1/2 plus c. Now you'll note I'm still making sure that every single one of these equal signs is truly equal to each other. I'm including the plus c because I've now converted this to an indefinite integral. I'm still making sure all my communication is on point. But now that I have what my indefinite integral is, I can restate the original problem, which was the definite integral from 3 to 5 of this same integrand, right? And this is going to be equal to 2, what was my u? X squared minus 3x plus 1 to the 1/2, right? I'm just rewriting this, but with my u plugged in. And now I'm going to evaluate that from 3 to 5. And then I can plug in my 5 and my 3 as opposed to the 11 and the 1. This will get me to the same thing. I'm still going to end up with the 11. We've already done this work of plugging in 5 because I did this before. And then we're going to have to subtract off 2 times 1 to the 1/2. It will end up with the exact same answer. But there were a lot more chances, in my opinion, for communication errors here because a lot of students still had equal signs floating around in places that weren't equal or they forgot their plus C's, right? I had a lot of students that went, okay, cool, this is this. And then wrote down next the actual plugging in of numbers. And we know an indefinite integral does not equal a number, right? So that was a moment where things were a little bit off. And I circled and sort of just was like, nah, let's not do that. So anyways, those are the two ways to have tackled this problem, the purpose of which was to verify that you could properly communicate doing u sub in a definite integral. How do I stop this?